are a little bit more difficult to identify. So we're going to spend a little bit of time talking about these. All right, so a horizontal asymptote it's a value of y, okay? A vertical asymptote is a value of x. So a horizontal is a value of y that a function will never output. But it will approach it slowly. So we're going to take a look at a particular function here on your calculator again. So go ahead and take those out. And we're going to do 2x divided by x plus 1. And be careful of how you type it in. Should have parentheses like that. Now, this particular function has a vertical asymptote and it has a horizontal asymptote. So when you graph that, standard window still should be good. We can make it smaller if we need to, but okay, so it looks like that. All right, so where, yeah? Yep, it does do that. The 83s will connect the dots here. So it's inadvertently graphing an asymptote, while actually what the calculator is doing is connecting the dots. So it looks like an asymptote. But in any event, where is the vertical asymptote for this one? -1, right? And you can see that in the graph. Okay, right here. That's that one place that's going to make that thing undefined. So you can't plug in a -1. There's where the vertical is. Now, take a look at the graph. Where do you suppose the horizontal asymptote is sitting here? Yeah. It looks like it's at 2, right? It's this kind of imaginary line that if you put it through 2, okay, the function is coming up and approaching it, but not quite getting there. It's kind of hard to see because it's all pixelated, but that's the idea. So I'm going to sketch this graph on here so you can kind of see it a little clearer. And we'll talk about this. So we had x equals 2x over x plus 1. And from our graph, we identified that it had a vertical asymptote at -1. And when we sketch these things by hand, we use dotted lines for those. Okay, so there's that vertical asymptote at -1, and then we said that there was a horizontal one at 2. So it's kind of this imaginary line again, make a little dotted line. And then our function was doing kind of this in between them. It was approaching all of these asymptotes in different ways. Okay, so it has that kind of a look to it. All right, so that horizontal asymptote said it's a y value that the function's never going to obtain, or an output it'll never get. Does that make sense looking at that graph? Okay, it's never going to cross that horizontal line. Okay, so it's not going to get there. But it does approach slowly. So as we go out towards infinity, or as we go out towards -infinity, it's slowly approaching that. Okay? So that's kind of what a horizontal asymptote is, how it functions in a graph. Now, how do you determine what the horizontal asymptote is from the equation? Like the vertical ones were easy, right? We just look for the denominator and what's happening there. Horizontals, it's not the same case there. Okay? This one had a horizontal asymptote of 2. Okay? If you look at the equation of this thing, okay, we got a 2x on top, and we got an x plus 1 on the bottom. Think about, what if you put in super huge numbers in for x? Okay? Because as this thing goes out and it becomes super huge numbers for x, we should be getting closer and closer and closer to what value? 2, right? Okay, so let's play that game with this real quick, because we should be getting a 2 if we're putting in super huge numbers here. So put in like 100. Okay, what are we going to get on the top? 200. What are you getting on the bottom? 101. What is approximately 200 divided by 101? It's pretty close to 2, right? Not quite. It can't be exactly that, right? Because it's never going to get there. But it should be very close to 2. Now, if you plug in 1,000, 2,000 divided by 1,001, it's even closer to 2, right? Not quite there yet, but it's even closer. If you put in 1,000,000, 2,000,000 divided by 1,000,001, really close to 2, but not at 2, right? So if you keep playing that game, you can kind of see where it's going, okay? It's called its end behavior, okay? That's why we have that as one of the things we're going to talk about with horizontal asymptotes, because it's kind of all one and the same, okay? So we can identify that the horizontal asymptote of this thing is going to be 2. In horizontal asymptotes, we use y equals instead of x equals because they're y values instead of x values. All right. Now, this super huge number thing, bless you, will always work, okay? But there is a little trick we can use to kind of simplify this strategy up a little bit. This equation in a certain way so that it would have a horizontal asymptote always. So you've got 3 cases with horizontal asymptotes, with equations of how it might go. So if the degree of the numerator is greater than the degree of the denominator, no asymptote. Okay, so and it's going to be what are called rational functions. So it's going to be something over something. So if the top has a larger degree, okay, it's going to, in a sense, grow more quickly than the denominator. Okay, so think about that. If the numerator of a fraction is growing more quickly than the denominator, what's the value of the entire function going to? If the top grows faster than the bottom, then the entire number is going to do what? Get bigger. And it's going to go off to infinity. Okay? So no asymptote. It's not leveling off to anything. It's just going up. Okay? So if the degree of the numerator is larger than the degree of the denominator, no asymptote. Now, the reverse is true, though. If the degree of the denominator is larger than the degree of the numerator, so let's consider that. I bet you guys can come up with it for me. If you have a fraction where the denominator is growing more quickly than the numerator. Okay? Denominator is getting super huge. Numerator, not so huge. Where are we approaching? What value is the fraction getting really close to? 0. When you have a fraction that has a super huge denominator, like 1/1,000,000th, very close to 0, right? It's just a super tiny thing, real close to 0. So if the degree of the denominator is larger than the degree of the numerator, that denominator is going to grow really quick, the numerator not so much, so that fraction then is going to approach 0. And so your horizontal asymptote is always y equals 0. And the third case is the case we've already looked at, is the example I gave you. This one. What's the degree of the numerator? 1. What's the degree of the denominator? The degrees are the same. We've covered the other two cases, right? What if one's bigger than the other? But in this case, both degrees, this has a power of 1, a power of 1, that's it. They're the same. The answer for this one was 2. How do you think I could get 2 just by looking at it? Okay, consider this for a second. Oh, did you have an answer? I'm sorry. The coefficient on the numerator, okay. Yep, and in this case that's true, but it also relates to the coefficient on the denominator too. If x gets really, really big, does this plus 1 really have much of an influence? No, okay. So if I pretend it's not there, what do I have? 2x over x. Simplify that for a second. 2. There's your answer. You divide the coefficients. Okay? So if I had 2x over 3x plus 1, the horizontal asymptote would be 2/3. Okay? So you have to divide whatever those leading coefficients are on both of them. Okay? So that's our third case. So if the degrees are the same, then you're going to divide leading coefficients. Okay, so let's practice this a little bit. All right. So without even looking at a graph, just the equation. What is the horizontal asymptote of that function? Yeah. -1/2. Good. Tried to fool you there, but apparently Mr. Verberg didn't fall for it. The degree of this is 1, right at the top? Even though I wrote the 3 first, technically the leading term is the x, right? So it's -1 plus 3, really. And so -1 divided by 2, because those degrees are the same, -1/2. Okay. How about 1 over x to the third? Does it have a horizontal asymptote? And if so, where is it? Yeah. 0. Good. How do you know that's 0?
Because the degree on the bottom is greater.
Right. So y equals 0. Good. Okay. And we'll do one more. Okay, what about that? X squared plus x minus 1 over x. So what is it? No asymptote. Mm-hmm. Degree on top is bigger than degree on the bottom. It's not going to have one.